So for complex numbers, here's basically what we're looking at. And this will back up to a little bit of what we were doing not too long ago. 15. Okay, so with the solving, let's back up to, and then this would be one we, on the last test, we would have had you solve this one by using the square root property. Okay. So if we're doing square root property on this one, you would square root both sides. And we get x equals, and again, because it's x squared, we're looking for two answers. We would get the plus or minus 4. Okay, so that was what we were doing, kind of one of the things we were doing on the last test. Here's where we're going to add in something new for this one. Oh, sorry, I forgot the title back up here. All right, so it should be complex numbers for this one. I put complex, forgot to put the numbers on it. All right, we're going to do a what if here. Okay, and so for the what if on this one, we're going to have a what if a squared equals negative 25. And if you check that on the calculator, here's the problem. Yeah, the glare's going to see it. You get an error message. So if we try to do that one, because again, we would square root both sides. And if we do that, we get the error message. And with the error message, now that goes back to the last test. Y'all remember when we did the discriminant, how we said you have either two solutions, one solution, or no solutions. This is that no solution part, because on this one, you get the error message, which means there's no real solution. When you take the square root of a negative number, that's going to give us that error message. And so what we're going to look at today is, all right, well, here's what we're going to do. It's not going to be a real solution. It's going to be an imaginary solution or a complex solution. Okay, and that's what we're going to look at today for the part that we're going through. That's where it's going to change because of how the solution we're looking at, how it's going to go. Okay, and with imaginary numbers, they're going to use the variable I. And when you see the I variable, it's always going to be an italicized I, or it's usually some type of way that's not going to be it's not going to be a capital I. It should always be a lowercase I as you're going through this one. Some people think it looks like an L because of the way it's written, but it's an I. So they're always going to have the variable I for this thing. So up here, that on the last test, that if we had square root of negative 25, that was going to equal no solution. But here's what we're going to do different for this section. Now we're going to replace the negative with I squared. Okay, and the one big thing we got today with this one is that when we have I squared, or when we have a negative inside the variable, we're going to take the negative and replace it with I squared. Okay, so that's the big thing today that we're doing for all the parts we've had for this one. So here's basically what it is, and we'll show you how we're going to do this one different. So last test, if we were doing the discriminant and we had a negative number, we said, all right, no solutions. We were done with it. We weren't going to do anything else with it. Here's where we're going to make that change for this part of it. That for this one, we're going to ask you to solve x squared equals negative 25. We're going to get an answer. It's just not going to be the answer we've had before. We're going to change it just a little bit. Okay, so we're going to go ahead and square root both sides. I'll pull this up just a little bit here. Okay, and anytime you square root a negative number, this is the new thing we're going to do for this chapter as we're working through stuff. That where we have the negative 25, and again, if we check that, we're going to get this error message, which means it's not going to work. So what we're going to do is we're going to take this negative 25 we have, we're going to rewrite it as where we've got this, think about like negative 1 times 25. Now, here's the thing. You're not going to have to do this every single time. We're going to show you how to get through it the first time, and then after this, you can kind of shortcut it to get to the answer you're going with. But we've got negative 1 times 25. We're going to take out this negative 1. And rewrite it with I squared. That's just because y'all beat calculators. And what? Okay, and then from there, we're going to square root both of the sides we've got. If you square root 25 and it's positive, now just to make it look a little better, we're going to switch it up, put the 25 first and put the I squared second. If you square root 25, you would get 5. And if you square root I squared, well, I squared is the same thing as I times I. That's your, buddies we've got. If we're doing the exit buddies on this thing, you've got an I that would get out of it. So this thing is just going to be 5I. Okay, so with that one, now here's the thing. If it's x squared, if it asks you to name all the solutions, you're still going to put the plus or minus on there. If they ask you for just one solution, you don't have to worry about putting the plus or minus. So if it's solving and they say to list all the solutions, you'll put the plus or minus 5I. If they ask you for just one solution, you can just leave it as 5I, so that's going to depend. So here's the big thing. The only thing different today that we're doing that we weren't doing last week is if you squared in a negative number, last week we said you would put no solution. The only thing different today is if it's a negative number, you're just going to put I at the end of the problem. So you would square root the number, pretend like it wasn't negative, and if it is negative, you just put an I at the end of it. That way you let you know that's a negative number. So that's the only difference. The square roots, everything's still going to be the same thing as you go through this one. So if we're doing, negative square root of 49, if they ask you to simplify, forget about the solving for a little bit. What if we have to just simplify in this case? Let's it's negative square root of 49. Well, again, if we know if it was square root of 49, that would be 7. And because of the negative that's here, just put an I with it. So if it's solving, we'll put the plus and the minus with it. If it's just simplifying, you don't have to put the plus and minus. You can just put whatever there. So if it was, square root of 100, that was negative. We know square root of 100 would be 10, but because of the negative on the inside, you just need to put an I in the answer. Okay, and that's the big change we're kind of looking at for this first part. That before we had square root of a negative number, we didn't do anything at all to it. We said it was no solution. Today we actually get a solution, but we're just going to put I in there to let us know it's a negative number. Okay. All right. So now it still works the same way if you had a non-perfect number and you had to simplify it. Let's say it was square root of negative 20. You would still take it, break it down just like we did before, but we'll just put an I at the answer on it. So for this part, and again, we're just going to ignore the negative for a little bit. If we take 20 and break it down, I'm going to do the stack method over here, the ladder method. Take 20, you can divide it by 2. Take 10, you can divide it by 2. So that gets you the 2 times 2 times 5. Okay, there's your pair of 2's. So the 2 will get out. The 5 will stay on the inside. So if it was just square root of 20, it's 2 square root of 5. If it's negative, again, the only thing you have to do different is you need an I at the end of the answer. Sometimes they'll let you put it here. Sometimes they'll also write it so that you put the I there. And whichever one you do, either one's fine. It doesn't matter. You just need an I. Now, the I cannot be in the square root. It's got to stay outside the square root when you're doing this. Okay, so and again, that's the big difference we're looking at. If we're squaring a negative number, you just use the I in the answer to let you know that it was a negative number to get started with. Okay, so there's the first part of kind of what we're looking at today. So again, whether it's simplifying or solving, if you're square rooting with a negative number, do the number, just ignore the negative, and at the end, just put the I back in the answer, and then that way it's what we need to do. So that's the one minor difference that we've got going today. That would work the same way when we did the quadratic formula. That would have been the same thing if we'd had a negative number inside the square root with a quadratic formula. You'd get the plus or minus. It'd be like this. You get the plus or minus 2 square root of 5i. So that would have been the same thing we would have had there. We may look at one of those later just so we can kind of see what we got there with. Okay, second thing we've got with the I variable, we're going to do powers of I. And this is going to be one of those where if we're going through this one, it's more of a calculator type question. But it's really just one little thing. It's more of just kind of how it is for this one. So okay, so they're going to give you a problem, and it's going to be just this. It's going to be I to some power, I to the 20th, I to the 36, I to the 49, it could be I to the 144. Doesn't matter what it is, it's just I to some power. And to simplify I to the power, you're going to divide the power by 4. Okay, and I'm going to show it to you like the way you would do it by hand, but we'll also show it what we do with a calculator. The remainder tells you what the answer is. Okay. All right now. Okay, and basically here's what it is. If your remainder, which we'll just call R in this case, if your remainder equals 0, then your answer equals 1. And we're going to do this by hand over here. We'll do it with a calculator over here. So we're dividing it by hand over here. We'll show you calculator in a second what you get. If your remainder equals 1, then your answer equals I. If your remainder equals 2, your answer is going to be -1. And if your answer equals 3, your answer or remainder is 3, your answer is going to equal -I.
What is that?
Which part? You got it? Okay. Okay, so that's if you're doing it by hand. Now, we got calculators. So we're going to say with calculators. If your remainder equals 0, well, it's still going to be the same thing. If your remainder is 0.25, we're going to have that. If the remainder equals 0.5, we're here. If the remainder equals 0.75, we're there. Okay, so if you're looking through anything, that's a 0, not a 6, by the way, there. There you go. So if you're looking through anything as far as like the book goes, the book will always talk about remainders, like doing it by hand. We're doing this one. If you're using a calculator, you're looking for the decimal numbers. So you're looking for 0, 0.25, 0.5, or 0.75. But these are the answers that you're going to have. This is basically, and this was an easy multiple choice question because we'll give you those 4 options. You just got to know what the answer is going to be. And there's not really any work to show on this one. We'll do 3 just to make sure we got it here real quick. Let's do I to the 63 power. Some people say that looks like a C. Well, no, it's an I. It's not an L. It's not a C. It's an I. It's a cursive italicized I, usually the way they show it. Sometimes they may just put like a lowercase I, so it's like that. But it'll be an I in there some way, shape, form, or another. Okay, and all you do is you take your calculator out. You take 63. And you divide it by 4. And again, all you're looking for is your remainder. In this case, we got 15.75. So your remainder is 0.75. So your answer is -I. So again, we do 63 divided by 4, which is 15.75. And again, we really don't care about the whole number part. It's the remainder that we've got here that tells you what the answer is. So the remainder is 0.75. So that means that the answer is going to be I, -I. So again, it's all just about the remainder that we're looking for. Okay, if it's I to the 64, just changing it to be something different there. Again, you're just going to take 64 and divide it by 4. If you do, that comes out to be 16, which means there is no remainder, right? So if it comes out evenly, remainder 0. So then your answer is 1. Okay, and again, it doesn't matter how big, how small. The number could be I to the, somebody give me something up in the hundreds. Give me a number up in the hundreds. What? How about 570? All right, so we'll go 570. Okay. All right, same thing on that one. If it's 570, you take the 570 and just divide it by 4. All right, we get 142.5. Okay, and with the 0.5, that's what we're looking at here. The remainder is that, so the answer is going to be -1. Okay, good. All right. So again, take the number, divide it by 4. It's the remainder. Whatever the remainder is, that's going to point to what the answer is going to be. And again, that's every question. That's all we're going to do. Just take the number you got, the power you have, divide it by 4, and then that's all you're looking for. Okay, so that's kind of the basics. That's the main things we're looking at. So you're square rooting, and then you've got just the powers of it. Now here's the part where we're going to kind of bring in, I guess, like the actual math part of it. This is where we're going to go back and everything else we've been doing, like the x plus 2s and the x minus 3s. We're going to do that same thing with this one, but now we're going to use the I variable instead of the x variable when we're going through these. Okay, so for the next part, we're looking at number operations. It's not just the complex numbers, but we're actually going to, start adding, subtracting, multiplying, that kind of thing with it. Okay, and the first thing we've got is they're going to talk about complex form. And that's A plus BI, where they're going to put the A is basically where you got a real number. And then whatever's got the I part, that's going to be the imaginary number. Okay, so complex number operations, they'll always write the answer so it looks like that. So if we're talking about something like this, just an example of it, this could be like 2 minus 3i. That they'll put the real number part of it first, they'll put the imaginary number part of it second. If you switch it up and put the I first, it's still okay. But they say, all right, if you're going to actually write it in what they call complex form, you always put the I part of it at the end of it. Okay, and we've got 2 things we've got to do with complex numbers. We're going to add them or subtract them, which is basically the same thing, and then we're going to multiply them. Okay. And of the 2, this one should be the easier one because there's a lot less stuff you've got to do with adding and subtracting. We're going to do multiplication, got a few more steps to it. So this is one, it should go pretty easy because there's not a whole lot of stuff that you got to be careful of here. Okay, and when you're adding and subtracting complex number, you treat the I variable just like you would any other variable. If it was X or Y or B or Z or T, it doesn't matter what it is. So you're not really going to do anything different. And what it comes down to with this one, all you're going to do is you're going to combine like terms. So you actually get to go back to like 6th grade math on this one, 7th grade math maybe, a little bit of 8th grade math. Yeah, yeah. So it probably should have started like in 6th grade. They would have kept going all the way up through algebra 1. Actually, you would have done some of this in geometry last year too, when you were solving equations or when you were solving the triangle, trying to find the angle or the side lengths. You would have done some combining like terms for this. Okay, and with adding and subtracting, the big thing is you've got to be careful because sometimes people try to do too much with the adding and subtracting that they try to basically kind of looking past it here. So. Okay. Now the best thing is with addition, there's nothing you really have to do other than you just separate out the numbers of everything that's here. So where you've got the 3 and the 6, we're going to separate those two things out and kind of pull them out. So we've got a 3 that's here and a negative 6 that's there. And then for the 2i and the plus 5i, we're going to put those two over here. Okay. And then from there, you just add or subtract whatever the signs say to do. It's 3 minus 6. That's a negative 3. You've got 2i plus 5i. That's 7i. And that's your answer. And that's all you have to do. So there's not really anything tricky with the addition part. You just have to be careful that, again, with addition, you just pull out the real number part of it first. Anything with the I variable, you put that out second. Just make sure you take the sign that's in front of the number. That negative has to go with a 6. That positive goes with a 5. That positive goes with a 2. The 3 didn't have a sign, so we just put it first. If you need the sign there, it would have been technically that would have been a plus because there's no sign in front of it. But they didn't give us a sign, so we didn't really need the sign there. Okay, subtraction, almost as easy. And subtraction, really, it is just as easy. But there's just one thing you got to be careful of. It's not hard. It's just hey, be careful because somebody in here, there's going to be about 5 or 6 people that's going to do this. I could stand on my head and turn cartwheels, and somebody's still going to do this. That you just got, it's not hard, just you got to be careful with subtraction. Sometimes people get in too big a hurry and they fly through it and they'll mess it up just because they're getting in hurt. Okay. If you're going with subtraction, basically it's the same we did, and again we practiced it. Now it's been a month ago, but we practiced probably maybe a little longer than that. No, probably about a month ago. We were doing this back at the beginning of August. That we were doing some order of operation stuff. This is one of the combining like terms worksheets we did like in that first week of class. That the 4 minus 5i is good. Anywhere you've got a minus sign in front of the parentheses, you've got to change the numbers in here first. So this is really going to be a negative 6. And most everybody would change that one. They'll forget. A lot of times people forget to change that one to make that a positive 9i. Where you've got a negative in front, that means you got to change both signs. It really, it's like negative 1 times 6 minus 9i. So you're basically doing negative 1 times 6 and then negative 1 times 9i. Again, you don't necessarily have to write that down, but that's kind of where you got a negative. That's what you want to think about. That you're going to change, and that's why you're changing both of the signs because it's really like having a negative 1 with that minus sign that's there. Okay, and once you do that, and it's only the one on the right side. Once you change those signs, now you're basically back to doing addition. You can pull out the whole number part. We've got a 4 and then a negative 6. You've got the minus 5i and now a plus 9i. Okay, so then it's 4 minus 6 for negative 2. Negative 5i plus 9i, that would be a plus 4i. And then you're good to go. All right, one more subtraction, just make sure we're good. Okay, and again with subtraction, you don't do anything to change the first one. The first one's good just like it is. It's the one that's got the minus in front. That's the one you've got to change both signs. We've got the minus in front. We're going to change that to a positive 5, and then change that to a negative 4i. Okay, and then once you do that, then you're just adding or subtracting whatever the signs tell you to do. We've got the negative 7 and then the positive 5, so we'll put those two things together. We've got the plus 3i and then the minus 4i. So we'll put those two together. And again, from there, you're just adding, subtracting whatever the signs say to do. It's negative 7 plus 5, that's a negative 2. It's 3 minus 4, that's a negative 1i, which you could leave that way. You also could just do negative 2 minus I. Either one of those two answers would be fine. Okay. So, again, not a lot really going on with that. You're just basically just combining like terms. And again, not anything hard, but subtraction. You just got to be careful because somebody on the test is going to miss that sign. It's always the second sign. Everybody changes this one. It's this one that everybody forgets to change. And that one little number is going to throw everything off, and you're going to get the wrong answer just because of one little sign there. Because somebody's going to say, oh, I got 7i on that one. And I'm like, well, yeah, because you forgot to change the sign. Okay, so here's the moment of the day. So this is the part we need everybody to kind of lock in. How about 2? There we go. Okay. Okay, so here's the part where I need it, because that's pretty straightforward. That one you could probably look at an example and miss it one time and go, oh, okay, I figured it out. This is the part where I kind of need everybody locking in on this one. Okay, when we start to multiply complex numbers, it's either going to be one of two things. Question. It's either one of two things on this one. It's either going to be distributed property, or it's going to be doing the full. And it's still going to work the same thing for this one. Okay, so it's going to be one of those two things. It'll just be a mix, probably more full method than it is distributed property, but you'll still get both. Okay, now this one's got one little extra thing to it. You're going to treat I like any other variable until, because it's not a matter of when, but until you get I squared. When you get I squared, you're going to replace I squared with negative 1. Okay, so it's the same thing we did earlier in the year. We're still going to add, subtract, do all the stuff we've been doing with the, and again, still, it's just in the full method, it's just double distributed property. Instead of multiplying once, you got to multiply twice. We've been doing some of that. The only difference for this one is that you're going to run across some of these problems, and you're going to get I squared, and where you have an I squared, you have to take the I squared out and replace it with negative 1. If you don't get I squared, you don't have to worry about it. Okay, so here we go. Here's the first one. We're going to do 6i times 2 minus 3i. So for this one, starting off with just a distributed property, we'll move up to the full method on the next problem. Yeah. And with the 6i on the outside, that just means we got to take 6i, multiply it by 2, take the 6i, multiply it by the negative 3i. When we do that, you get 12i. And again, here's the part where somebody's going to miss this one. 6 times 3 is 18. That's a negative. When you do I times I, that will be I squared. Somebody's going to forget that I squared part. They're just going to put the I, and then that's where they're going to kind of get lost on this one. That's the one thing you got to be careful of. That when you do I times I, you will always get I squared. Okay, and again, wherever you have I squared, you're going to take out the I squared and replace it with a negative 1. So that really means that's negative 18 times negative 1. Which means that's negative 12i. When you do the negative 18 times negative 1, you make it a positive 18. That's still the right answer. It's just not in the form that they wanted. So for that one, we got to do one small thing. We're going to put the 18 first, and then the 12i will go second. Okay, and with multiplication, you're going to have to basically do that, I would say, every single problem. They might sneak one problem in where you wouldn't have to have I squared, but if there was 100 problems on there, you're probably going to have 99 that's going to have an I squared in there somewhere. All right, so for example 2, this one will make it where it's a full method. And again, full method just means it's double distributed property. Okay, so first time we're going to do 2 times 4. And we're going to do 2 times I. Okay, 2 times 4 is 8. 2 times I is 2i. All right, second time. The second distributed property you're going to do is now we're going to take negative 3i, multiply it by the 4 and the I. So we've got negative 3i times 4. That's a negative 12i. When you do negative 3 times, and if you need the 1 there, you can always put that in there. Negative 3 times 1 would be negative 3. And then when you do I times I, that is I squared. Okay, and the difference is before when we were doing this one. You did x times x, we get x squared. This time we're doing I times I, we're getting I squared. The x is not first. Now the I, the way they have it, they always put the I second. So whenever, again, when you do the I times the I, you're going to get the I squared. So the 8 is good. When you do the 2 minus 12, now here's where we're kind of going back to the other part. Because of these two terms in the middle, you've got the 2i plus or minus the 12i. Those two you combine together. 2 minus 12 is negative 10. With the I. And then on the end of it, we've got the I squared. Again, you're going to take out the I squared and replace it with negative 1. So that's negative 3 times negative 1. That's going to make it a positive 3. All right, and now you've got 8 plus 3. So you can take that part and just make it 11. The negative 10i or the minus 10i, whichever way you read it, that part will go at the end. Yeah. Now, some people, different ways of people being taught different things. Sometimes people did this one with like a. Some people did that same multiplication like with the box. If you did the box part of it, that works out okay because then you got 2 times 4 for 8. 2 times 1i would be 2i. 4 times 3 would be negative 12i. that one you get a negative 3I squared. If you do it that way, it's the same thing. It's just, the numbers are just in a little different arrangement, and that's fine because it's still going to get you the same answer. So I know that was kind of when y'all were coming through elementary school the last couple of years, they might have shown y'all doing something like this with some different ways, different parts along the way. So you don't, there's different ways to kind of get to that answer to get there. Do it. Okay. One more of these. Now, when the answers on these, the answers can be all kinds of different ways, and we'll show you one where the answer is going to look a little different, but it's still a correct answer. So just want to kind of show you that one because the last two we've had, these two answers look the same, but the numbers are just a little bit different. Okay, so again, same problem on that, or different problem, but just so you can kind of see what's happening with it here. All right, so distributed property with a 6. We got 6 times 6 for 36. We got 6 times negative 5, which would be negative 30, and then the I. And then we're going to do the same thing with the 5i this time. So we got 5i times 6, which would be a positive 30. 5 times negative 5 would be a negative 25. I times I would be an I squared. Okay. Again, if you go with the box method, it would look a little different. But again, same 4 numbers, just in a different arrangement of numbers you got. And it should be pretty much the same setup every single time as you go through these. The first number should always be just a number that you're not going to do anything with. The next 2 numbers in the middle, these are the ones that you're going to add or subtract. Well, what happens when you do 30 minus 30? You get 0, right? If you do 0 times I, that's just a 0. So we've got 36. We're going to add 0 to it, which isn't going to do anything. And then at the end, we've got the negative 25I squared. But again, because of the I squared, we're going to take out the I squared and replace it with negative 1. So if we do negative times negative, that makes that a positive 25. So this is one of those problems where and sometimes this will happen, the I term just kind of goes away, and we're left with 36 plus 0 plus 25. So the answer is just 61. Okay, so just depending on the numbers, sometimes the I term goes away. There may be some problems when you do these that the whole number goes away, and your answer may just be like negative 10I. So the answer can be any one of a bunch of different ways. So again, it could be 61, it could be 11, it could be negative 10I. So, the answers are going to look a bunch of different ways as you go through these. Okay, and then the last little thing, and this is just like one example to show you this one. There's going to be some we're going to ask you to do some operation type stuff. I'll just show you one of these real quick to get something like this. Yeah, just a minute. Mm-hmm. Okay, so the last one we'll look at, maybe something like this. Okay, so you've got 2 plus square root of negative 9 plus 6 minus the square root of negative 100. If you have one like this, same thing on this one, kind of like we did way back in the very first few problems, where you've got a negative square root, you've got to fix that part first. Okay, if you do the square root of 9, we know that would be 3. And because of the negative on the inside, You just make that an I. Okay, if you have square root of 100, that would be 10. But with a negative, again, just got to put an I there. So if you're given negative square roots, you got to fix that part first. And again, if it's a negative square root, you need to put the I in the answer and you square root the number. So we took square root of 9, made it 3, but because it was negative, we'll make it 3i. Square root of a negative 100 would be 10i, because again, the I kind of lets you know it's a negative number. And then from there, now it's going to ask you to add it, subtract it, whatever it's going to ask you to do. Now this one was addition. So we're going to put the 2 plus 6 together. We got a plus 3i and then a minus 10i. Okay, 2 plus 6 for 8. 3 minus 10i would be a negative or a minus 7i. Okay.